All right, so we're going to take a moment and we're going to go through an entire graphing problem, one of these quadratics, start to finish, looking at all the different parts, learning how that we've been learning how to find over the past couple of weeks. So let's start by looking at this example. We have x squared minus 2x minus 8, and right below we have our list of things that we're looking to find. So we want to find our axis of symmetry, find our vertex, find our roots and zeros, find the domain of the range, and we're going to go ahead and graph the entire function. So, quick reminder, when we're talking about axis of symmetry, what we're talking about is that invisible line that runs right down the dead center of our parabola, okay, of our graph inside. So we can fold one side over onto the other and they match up. When we're talking about our vertex, what we're actually looking for is that little point right at the very bottom or top of your parabola that's, again, in the center of the graph. Okay, that's that minimum if it's at the bottom or the maximum if it's at the top. And that is also a turning point in the graph where slope changes from negative to positive or positive to negative. When we talk about roots and zeros, what we're talking about are those x-intercepts, how many times it crosses the x-axis, and our domain and range, we're talking about our x values, and then the range is the y values. And for both of those, we're looking for all those points where the graph is valid, okay, where the graph actually is valid or exists. So every point on the y or x axis where the graph actually still exists. And finally, we're going to go ahead and graph it. So let's move on. Here's our example again, x squared minus 2x minus 8. So let's start by finding our axis of symmetry and our vertex. If you remember, our axis of symmetry is very closely related to our vertex. The axis of symmetry is this negative b divided by 2a, and our vertex is a coordinate pair where the x coordinate is negative b over 2a, and our y coordinate is the f of negative b over 2a. Let's start by finding the axis of symmetry. To do that, we need to go ahead and identify our three important values, our a, our b, and our c. And for this, in fact, function, what we need to make sure is that a is 1, b is negative 2, and c is negative 8. When we start taking these values and plugging them into our formula for axis of symmetry, we get the negative of negative 2 divided by 2 times 1. Work that out, the negative of negative 2 is positive 2, and 2 times 1 is 2, so 2 divided by 2 is 1. So we've got our axis of symmetry. We can come over here and we can say that our axis of symmetry is x equals 1. Now remember, we're defining a line, not just a number. So you always want to make sure that it's x equals that number for the axis of symmetry. Let's go ahead now and we'll come back and find our formula for vertex. Our vertex has that starting point that is our x value, axis of symmetry of 1, and our y value of f of negative b over 2a. So hopefully you remember that f of negative b over 2a, what that means is that we're going to take our value and plug it back in to our original equation, x squared minus 2x minus 8. So let's do that. Our original equation, x squared minus 2x minus 8, and we're going to plug back in 1 every spot that we have an x. So what we get is 1 squared minus 2 times 1 minus 8. We'll keep working. 1 squared is 1, minus 2 times 1 is minus 2, and then we're subtracting 8. So 1 minus 2 minus 8. 1 minus 2 is negative 1, minus 8 gives us negative 9. So our y value for the vertex is negative 9. So now we can come back, look at our list, and say, well, our vertex is this coordinate point 1, negative 9. Remember, a vertex is a point. It's a single value, not a line. It's just a single spot on the graph. So let's take a second and let's look at all of the rest of our roots and zeros. So as we come here to look at our roots and zeros, we notice that we have a problem. It's hard to figure this out without having to graph. We haven't figured out how to find them from the equation yet. So let's skip this and let's jump on to talking about actually graphing it. we need to figure out what we can do. So we can't graph, we have to graph it in order to find our roots and zeros and to find our domain and range. So looking at graphing, here's our grid. We take our grid, 10 by 10, pretty easy. We have our axis of symmetry, we have our vertex, so we can use that as sort of the basis. So we build ourselves a table, a t-chart for x and y values. We know that our axis of symmetry and our vertex is in the center, right in the center. And we need to take this vertex and find values on both the left or negative side and the right or positive side. So we mark our vertex 1, -9. And since that vertex is at the center of our graph, we can look at our t-chart and just say, well, the value of x being 1 has to be in the center, gives us a y value of -9. So now we have to have values on both the left or negative side and the right or positive side of that vertex. So think about what values are smaller or bigger than 1. Well, if we look at this, we can say that the one number less than 1 is 0. A number less than 0 is -1. We can go to the values on the positive side and say, well, the numbers right beyond 1 are 2 and 3. So these are the values that we want to find when we're looking to fill out our graph. So let's find those real quick. Throw this out of the way, and let's look at our original equation once again. So our original equation is x squared minus 2x minus 8. And we need to go ahead and find the value for -1. So we'll plug in -1. So -1 squared minus 2 times -1 minus 8. Keep working it out. -1 squared becomes a +1. -2 times -1 becomes a +2. And we're subtracting 8. So 3 minus 8 gives us a grand total of -5. So now we know that our -1 x value correlates to a y value of -5. Let's continue and double check our values. If we plug a 0 in, we get 0 squared minus 2 times 0 minus 8. 0 minus 0 minus 8 is, well, that's -8. So that gives us a value that we can plug back into our table of -8 for an x value of 0. Throw that out of our way. Now, we know that since we're looking for a quadratic function, which has that axis of symmetry right down the middle, that our values for 2 and 3 should match our values for 0 and 1. That is, the left side and the right side of the graph should be the same. Let's make sure that that actually works and that happens. So coming back, we've got our original equation, x squared minus 2x minus 8, and now we're going to plug in 2 and 3 for the values. So 2 squared minus 2 times 2 minus 8, well, 2 squared is 4 minus 8 gives us 0 minus 8, which gives us -8. So that's a positive. We can come back to our graph. We're still creating that symmetrical pattern, and so our value for 2 is -8. Come back to the right side. Let's throw in a value of 3 for x. So 3 squared minus 2 times 3 minus 8, well, 9 minus 6 minus 8 gives us 3 minus 8. Hey, that's similar to the previously, right? Gives us -5. This is a great sign. It means we're doing things correct. So our value of x being 3 gives us a y of -5. So now we have our x and y t-chart, and let's look at our graph and let's fill in our values. So we'll graph each of these points. Our initial point, 1, -9, our vertex is already marked. So let's go to the negative side. At an x value of 0, we can come all the way down to a y value of -8. From an x value of -1, we would drive down to a y value of -5. If we look at our positive half, we can look at our values of 2 and get a value of -8, and a value of 3 and get a value of -5. So all of this matches up, and that's exactly what we want to see. We can draw our nice little curve, and that's a pretty good approximation. Now, I'm no artist, and we don't expect you to be either. Unfortunately, as we're looking at this, we really can't tell exactly what the roots are. We can't tell exactly what point they cross the x-axis, so we need to sort of test that. Here's our graph from the previous step. We have our axis of symmetry, we have our vertex, and we have all of our points on our drawn parabola. So looking at this, it should be pretty obvious that there are two roots or zeros. That means that our parabola crosses our x-axis 2 times. Okay, so we've got one over here on the right, one over on the left, and so we can say that we have 2 roots or zeros. The second half of this is to look at what those roots or zeros are. Now, obviously my art's not great, so you can't quite tell exactly where it crosses our x-axis, but it's somewhere around 4, somewhere around -2. So let's go ahead, let's just sort of test. Let's see if we're close. We could just maybe figure out what happens if we plug in those values of 4 and -2. So let's start with our original equation, x squared minus 2x minus 8. And we'll start here on the right-hand side at +4 for x. So we plug that in, 4 squared minus 2 times 4 minus 8. Well, it gives us 16 minus 8 minus 8. So 16 minus 8 is 8. We subtract another 8, gives us 0. So that gives us a point of 4, 0. And that's good because that tells us that our graph actually does cross the x-axis at exactly the point 4, 0. So my graph is a little off. My blue line was a little bit too far to one side, but that's okay. We're not artists, we're mathematicians. Let's look at the left-hand side. Let's look at that -2. So -2 squared minus 2 times -2 minus 8 gives us 4 plus 4 minus 8. So that again adds up to 0. So we get that point -2, 0, which just like before means that our graph crosses perfectly at -2, 0. That's great. Again, it means my drawing's a little off, but we can live with that. So our zeros, if we come back to our list of things we're trying to accomplish, we've got those 2 zeros and 2 roots, and those roots exist at 4, 0 and -2, 0. And that's where our roots are. So now we can take this information and go ahead and move on and look at domain and range. So once again, we're here back with our original graph. So when we talk about domain and range, we're trying to think about what they mean. Domain has to deal with x, range has to deal with y values. So let's think about this graph. We have arrows at the top of our parabola, which means that our graph just keeps going. Even though we're not drawing it all, it's going to keep going forever and ever. So since we're looking at what a domain of x, we're looking at what happens as x increases. Even as you move up, even though it's not drawn, if you find an x of 9, the graph still exists somewhere way up here at the top. And that goes on forever, even when you hit to x of 1,000,000. The graph still exists someplace. If we look at the negative values of x, again, we're looking for that same thing. Does the graph exist somewhere along that negative x-axis? If we jump back to -10, even though it's not drawn directly on our graph, we know that the graph still exists way up at the top. Okay, so it's still there, which means that every single value of x has a y value, and that graph exists at every possible value of x. In this case, all real numbers are going to work for our domain. Now, if you remember, there's a special symbol that means all real numbers, and it's this kind of funky looking R with the extra bar. Now, range has to do with our y values. What we're looking at is, does the graph have y values, or does it have different x values for a y value? Let's start with our vertex. That minimum at the bottom is really important. What we're trying to figure out is what happens on either side of that point. If the value is above that point, the graph exists, because for every y value greater than our minimum in this case, the graph still exists. If you were to go up, for example, to y is 3, the graph still exists out there to the right and the left. Same thing at y is 10, still exists somewhere out to the left and right. But if we go to the negative values, we notice that the graph no longer exists. There isn't a graph there. Below -2, the graph doesn't exist. So y only exists above that minimum. So we need to say that y has to be greater than or equal to -9, which is our minimum. You'll notice that this value, that minimum value, shows up and it matches the y value of our vertex, which is going to be important. It happens every time. that something with your range is going to have to do with either your minimum or maximum, that y value for the vertex. So in the end, we can take this and say that, well, y is greater than or equal to -9. And that finishes it. So if we look at our original equation and everything we were trying to find, here's what we can do. We can find our axis of symmetry was x equals 1. That's the center of the graph. Our vertex, which is on the axis of symmetry, is at that point 1, -9. We determined from the graph that we made that there were 2 zeros, and those zeros were located at the points 4, 0, and -2, 0. Finally, we looked at domain and range and said that, well, our domain includes every possible x value, or all real numbers, and our range, in this case, happened to be that y was greater than or equal to -9, everything above the minimum. But that walks you through every single piece of all of these kind of graphing problems where you're given an equation you have to figure out. The only thing we didn't touch on was talking about minimums and maximums. All you have to do is remember is that if the a value, the value right in front, okay, that a term, if that is greater than 1, or a positive number, then you have a minimum. So if a is positive, then you have a minimum. It's equal to a minimum. If a is the opposite, if it's negative, then we have a maximum. So once again, when you graph it, you'll be able to see that as well. But these here, all these lines are the pieces and the parts to solving a quadratic function from start to finish until we get into finding roots through algebra rather than from the graph.